Hey everybody, welcome back to the channel and welcome to another Wells Index milling machine video. For those of you who are not familiar, this is my Wells Index model 847 knee mill. It's kind of like a J-head Bridgeport, only a little bit beefier. This is actually a milling machine that was made right in Michigan. So it's a made in the USA machine, and it's not very well known compared to the Bridgeports. But the select elite club of Wells Index owners like to argue that this mill is actually superior to a Bridgeport, and I'm not going to get into that argument. So the purpose of today's video is mainly just to do a quick demonstration of how the automatic downfeed capability on this mill works, because I've got my parts machine's head on the bench and I am going to attempt to disassemble this mechanism, this downfeed mechanism, on that to get some parts out for somebody who needs to replace some bad parts in their machine. My understanding is it can be a little tricky to get these gears and shafts out, so I figure we'll stumble through this process together. But I figured a good place to start would be to explain what it is I'm actually going after here for parts and how the whole thing works. So the power down feed basically allows the quill to come down at a very steady rate, directly proportional to the rotation of the spindle. So we can get a feed rate going down. Now, most of the drilling and other operations that I do, I just manually use the lever on the side here. And then when the gear train for the downfeed is in neutral, if we activate the power downfeed while it's in neutral, what that does is that locks in the use of this fine feed wheel, which is really handy. So as I rotate the fine feed hand wheel, you can actually see that it is moving the big handle. So this gives you the ability to kind of fine tune in and slowly manually feed. As soon as I press this lever down, it will release, and the spring, the return spring inside here, will actually bring the quill back up. That's when the system is disengaged. There are two neutral, well actually there's more than one neutral in the system. The first neutral is this lever on the left hand side right here. This lever right here has two positions, in and out. And the way that this works, whenever you're not using this, when you're not using the power down feed for anything, if you don't need to use it for any operations, the manufacturer recommends that you keep that gear train disengaged. That way, all of those gears and shafts and everything that are working in there are completely not moving at all. So there's no wear happening on those. So this lever on the side here, if you put it in the up position, that completely disengages all of the gear train and mechanism that has to do with the power down feed. So in order to get the power down feed to work, first we have to bring this to the end position. That actually moves a gear, a nylon gear, into position to actually start this whole gear train side here moving. The reason why that gear is plastic is so that if you crash, say, perfect example of why you would want to use power down feed. Power down feed is great when you're using a boring head because you have very fine control over the feed rate. Say you're using the power down feed and something happens and you crash the head, and this thing still keeps trying to move it, something's going to give. Well, that plastic gear is the sacrificial gear that's going to break and allow all of those more difficult and expensive gears that are inside here to survive the crash. This lever here engages that gear. Once that gear is engaged, we now have a lever on the side here. All right, so now we're on the right side of the machine and we have another lever here, and this lever actually has, the first position is the 1.5 speed, then there's a neutral, then there's 3, then there's a neutral, and then there's a 6. So to engage the power down feed, we need to have this lever also in one of these 3 speed positions. Obviously, the higher number, the faster the feed rate. I'm just going to put it in 3 for now. Now when I start the spindle, the down feed's still not going to move. The down feed does not move until I hit this lever to engage it. And then there's one other control on here, and that's this knob in the center of the fine feed hand wheel can be pulled out, and this is the reversing knob. This actually reverses the direction of the feed, regardless of the direction of the spindle. You'll notice this knob is rotating now because I have this engaged. But the spindle or the quill is not moving downward. There's no downward feed. The lever is not moving. But as soon as I engage this, you'll see now the handle's moving forward. It's actually going downward. It's kind of slow, so it's kind of hard to see it, but you can see the handle's moving. So now we've got down feed. If I pull this, now I just reversed it. See the handle's going back up. As soon as I press this down and it clicks, again, that disengages, the recoil spring allows the quill to come back up. Even though this is still turning, it's no longer feeding downward. If I have this knob in a neutral position, this knob will no longer be engaged. However, the other gears inside here that have to do with power down feed at this point are still turning when the spindle is on. So if I'm not going to be using power down feed, I want to make sure that this knob, this lever on the left, which is marked in and out, is in the out position. I like to keep this in neutral and this in the out position, just because, for whatever reason, I don't know. But that's how I do it. But I mean, that pretty much concludes how this operates. So now, let's take a look at that head that I've got on the bench and see how this actually works. Alright, so this ugly looking hunk of metal is actually the head off of the donor machine. It might be a little hard to recognize at first glance because I've stripped off so many parts, but this is where the rod would have gone that would have the depth stop on it, and the vernier would have been covering this opening right here. This area right here would have that metal block with the lever that disengages or engages the feed. This shaft right here is what had the fine feed hand wheel on it on my machine, and this is the knob that you pull to reverse. This is the lever on the side that has these positions, the 3 speeds plus 2 neutrals in between each, a neutral between each speed. So that's what this lever is. Over here on this side, this would be the left side of the machine facing it. This is the lever that has the in or out position and is used to completely disengage the drive, the power down feed drive mechanism from the rest of the spindle. So I'm noticing the last time this was put away, so to speak, it looks like this was left in the in position. This is seized. This is a pin. Supposed to have a knob on it that you pull out, that's supposed to be spring loaded, so that you can pull the pin out, and then that would allow this lever to be moved up. So that is seized in there, so I can't move this lever right now. In other words, it should work like this. See how I can pull this out? So if I pull this out, I can move this lever. Well, that lever's seized also. This has been stored outside on the ground under a tarp, and it doesn't look like the tarp was doing much. So looking down from the top, here is the main drive gear. So this gear right here engages teeth on another gear located on the main drive assembly when it's in this position. If we were to be able to pull this pin and move this lever up, what that would do is that would move this dog and allow this gear to slide down this shaft so that these teeth would no longer be meshing with the teeth on the gear here. And that's how it disengages. And just in the interest of being thorough in my discussion, this is the gear. Actually, these two gears are the gears that this is allowed to mesh with when this is engaged. Now, you may be wondering, why are there two gears? And the reason why there are two gears here is because this whole assembly moves up or down depending on whether or not this upper gearbox area is in high or low range. So high range, it's basically direct drive. The main pulley on the top of this whole mechanism is actually directly driving the spindle. And what ends up happening is when this is shifted into low range, the pulley on the top actually drives another pulley with another belt that goes over to a secondary drive. But we're not really, I don't want to get bogged down with that discussion, but all you need to know is that's why there has to be two sets of teeth, because one of these sets of teeth meshes with this gear when this is engaged in low range, and the other gear meshes with these teeth when this is engaged in high gear or high range. I lubed up this pin, got this freed up. So if I unlock it, I can move this lever a little bit. It's a little hard to move. So the lever's not really seized up inside here. It's this mechanism is a little stiff moving up and down. But you get the gist of how this works, moving the gear up and down. Got this dog, or this shoe, for lack of a better term. So the back side of this gear actually has a grooved section that rides in. Might actually be able to get this to, there we go. Well, there's the, once this clears far enough, the spring is able to fall out with this pin. So now I don't have a pin that I have to deal with anymore. I'm thinking if this part right here was disengaged from the shaft, I could pull this whole handle with the shaft out this way. That would drop out, and then I would be able to take this all apart. Looks like that might be a pin right in there. So there's a hole right in the center of that pin, so that makes me think that that's one of those roll pins, or they call it a spring pin. You know, it's a little tubular pin that's got a slit down the edge of it, made out of spring steel. Yeah, when I looked on the magnification, I could see there were little tiny stake marks where they actually staked over the edge of this hole. So, anyways, that pin is coming out now. All right, it's kind of pressed on there. Well, it occurs to me there's got to be something that keeps this shaft from just being able to slide out that way, because that space was already there. So there's got to be another step that I'm missing in order to take this shaft out. And there it is, right on the back side. Turned it over, so now I'm looking at the back side, and there is a Allen screw right here, a little grub screw. Might not even have to take that out. Might have to just back it out. And there we go. Now the shaft is moving that way. Actually, I already moved it out, so the pin has disengaged this shoe. There we go. So you see there's the groove that this rides in. Alright, now I've got the unit standing up, and I'm going to finish driving out this lever. Now I can clearly see that there's a bearing that supports the top of this shaft, and there are two screws that, if removed, they're what's retaining this bearing in that spot. So if I remove these two screws, that bearing could come out this way, but I kind of doubt that this whole shaft's going to come out, because I think there's going to be a gear down inside there that's going to not want to come out through that hole. But just for the heck of it, let's pull these two screws. Alright, I think it's time to pull this back cover off so we can see what's going on. Now, how much you want to bet that the clever engineers at Wells Index actually put these two threaded holes right here there, so that you could take the screws that you just took out, two of them, and drive them through these holes and use that force to actually pop this cover off. There's actually a locating pin right here, and there's another one I think under this dirt right here. So I think what's going on here is, I think that the three shafts here are all supported by bearings underneath these caps that are pressed into this cover. So I'm going to get a couple of longer screws and continue doing what I was doing, because that was working pretty well until I ran out of room. Bearing is pressed on the end of the shaft, and then the outside of the bearing must be pressed into this case. Alright, and now with these covers off, I can see that this bearing is pulling out here, and this shaft is pulling out of this bearing here. So the one that's giving me the problem is this one right here. The shaft is not coming out of the bearing, and the bearing's not coming out of the casting. So I'm going to just give it a little tap. See if we can't get that to come out. Oh, there we go. Alright. Alright, so I've started to disassemble this mechanism, and what I did was I slid off the gear that was sitting right here, and then it occurred to me that if I just start taking all of these gears out and wash them, then I'm not going to remember what gears went where, and I don't know if the gears are marked in any way. So I ended up deciding I better stop, and I printed out an exploded diagram that has part number callouts on it for the shafts and the gears, and then those reference this list, which is the actual Wells Index part number. So I'll be able to assign an actual Wells Index part number to each one of these parts. For right now, though, I just want to basically be able to keep track of what's what. So for instance, I know that this shaft, it's easy to differentiate which shaft is which, because on one side you have just a single shaft in the center, and then on the other side you have two shafts, one over the other. So on the side that has the two shafts one over the other, this is the lower of the two shafts, which according to the diagram is shaft number 104. So I know this is 104. So I know that the first thing that I would have seen was a spacer, bearing, spacer, the gear that I removed, a spacer between the two gears, which is this little collar, and next up would be this next gear. The problem with this next gear is I can't remove this gear because it's behind this gear on the shaft that's over by itself, which is shaft number 81. So I've got to get this bearing off so I can get this gear off of shaft 81. Oh, it appears this shaft will move out of the way enough so that I can slide this next gear off of 104, which with that gear off of 104, that clears the way for a whole bunch of gears to come off of this remaining shaft right here. Matter of fact, I wonder if this whole shaft will come out complete with the gears. Yeah, sort of. Okay, so I'm going to pull these both out together. And the reason why is because this larger gear on the standalone shaft actually is behind one of the other gears, but you can separate these just enough so that I can actually get this whole thing to come out. There's that whole assembly. So that's, what are we calling that one? 81. This. Now all the gears are out of the gear case. Let me clean them up. All right, I got some of the heavy grease off so I can get a better look at this mechanism and start to figure out exactly how it works. And it's actually pretty simple and ingenious. The way this works is we know that this nylon gear on the top here drives a vertical shaft. And as long as the in and out lever on the side up here is engaged, then it's in the in position, then this shaft is going to be rotating a worm gear inside here. The worm gear is going to engage this gear on shaft 81. So this gear engages the worm gear. This gear is key to this shaft permanently, as is this gear right here, and this gear, and this gear. This gear freewheels on this shaft, and we'll get back to this gear in a moment. We're concentrating on these three gears. So as long as the in and out lever is in the in position, this shaft is going to be rotating and all three of these gears are going to be driving. This is a 3-speed transmission. Speed is selected via this lever on the side, as we already knew. So how does it work? Well, this is going to be in here constantly turning because, well, like we just said, if it's engaged, this is always going to be running. This shaft has a worm gear that engages a large gear on the actual long shaft that goes through here that the quill handle is on. Okay? So when this shaft is turned, it actually is turning, you can actually see it's turning the quill, or the shaft that has the pinion on it that engages the rack on the side of the quill and makes the quill go down. Now I can actually stop this from turning just by holding it. And the reason why is because there's a clutch mechanism inside here that's activated by a handle that normally is on the front of the machine that I showed you when I demonstrated how this works on my working mill. Downfeed does not move until I hit this lever to engage it. This particular head, somebody needed that handle, so I already took it off and it's removed. So that's why that's not engaging. But all we really want to know is that this is the output shaft of the transmission, so to speak. So we know that this 81 is the input shaft, 104 is the output shaft, and that leaves the remaining of the three shafts, the one that goes here, which is unique in construction because it's this one right here. This one has these first three gears right here are not permanently keyed to this shaft. So this shaft has this slot in the end, and the way it works is there's a flat metal lever right here that moves in and out depending on how I have this speed adjustment moved. Okay? And what it does is it's actually got a little hook shape on the end of it, and it sticks up through. You can actually see this is a slot right here. It sticks up through that slot and actually acts as a key to lock in the gear depending on which position this is in. So if it's in the position where it's locking this gear in, now this gear is driven by this gear. Okay? And it works flawlessly because that key is so short that it can only engage one of these gears and not two at the same time. If it engaged two at the same time, it'd crash, right? It would be a problem. So once we get to the point where we've now selected one of these three gears by making sure this lever is not in neutral and has selected a speed, now this shaft is being driven. So this shaft is now under power. When this shaft is under power, what it does is it drives these two gears that are key to this shaft permanently. Why is it driving two? Well, the reason why it drives two is because depending on which one of these two gears gets selected by, go back to this first shaft we talked about, the driven one, the one that's driven all the time. You remember this gear that's just freewheeling here? I said we'd get to it in a minute. That's a reverser gear. Okay? So the way this works is these two gears that I already removed off of the end of this shaft. These two gears freewheel on this shaft. One of them freewheels and the other one isn't, depending on where this moving keyway, which is another flat lever, which goes to the forward reverse push-pull on the front. So if I push it all the way in, the keyway moves to the back, it's going to drive whichever one of these gears it was keyed to, okay? So that's how it reverses direction. So whether or not this gear ends up actually doing anything depends on whether or not it's in forward or reverse. But it's really kind of neat. I thought it was kind of cool. I thought you guys might find it interesting to see how this works. This video I figure will also be helpful to anyone who's torn into their gear case and is at the point where they mixed up some gears and aren't sure what goes where. All right, here's another assembly note I'd like to make. So the bearing sits very close to this gear, so I use one of these wedge type removers to get in there and pry that bearing off. In doing so, I ended up damaging this shim, which that's not a big deal because I'm not going to reuse that shim. Because the shim is probably sized depending on your assembly during reassembly, just like a transmission, figuring out which shim gives you the proper amount of end play. But the reason why I wanted to mention it is because the interesting thing to me is that there is a second shim on here, right there. So for whatever reason, there's two. So they had to put two shims together to get the correct amount of end play during assembly of this machine. All right, I've made quite a bit of headway with the cleaning and cataloging and removal of parts. These are the gears that I've taken off, cleaned a lot of the grease off, and I put the location numbers with a Sharpie, 82, 83, and 85, so these correspond to the exploded view, instead of writing the entire full part number on there. For the time being, I'm probably going to leave this whole assembly just the way it is. I'll just tag it so I'll know what it was for down the road. And this is the shaft that the gentleman who was requiring parts asked me to get him. And this, again, this is the one that the shaft and these two gears right here are an assembly. The bearing is separate, but I'll just leave the bearing on there and let him take it off. Same thing with the key is separate, but I'll leave it on there. So that assembly right there is going to be shipped out. So I'm going to scrap this head. I don't want to wait around till somebody, contacts me and says, hey, do you have the head for this machine? So I'm most likely going to scrap it. But before I do, I'd like to strip out what's left of the shafts and the gears in case somebody needs them. So I've got to get this shaft out, this lever that is actuated by this lever on the side here out, this shaft, which has the worm gear on it. I have to get that out. So in the process of trying to figure out how the heck to get that shaft out, I figured, well, this stuff on this end has to come off, and it probably has to go out that way, right? So that means this part right here that the fine feed hand wheel used to attach to right here, this has to come off this way. For this to come off, there is a spring clip or a just a regular clip retaining clip right here. Okay, that's easy enough to get take care of. But before that can come off this way, this little knob has to come off. Now, first thought was, does it just unscrew? But I can see, I clean this up down the side here, that this just turns and turns on that shaft. And then down in here, I could see there's no head or anything. It's not a screw that screws in that holds this on. So I'm like, well, what the heck holds this on there? And then turns out this was all covered with grease and oil, so I couldn't see it. But when you clean it off, and to be honest, the only reason I figured it out was by looking at the diagram, that there was a spring pin somewhere that was retaining in this pin that goes in from the top here. And sure enough, there is the spring pin right there. So I've got to knock that pin out, and that'll allow this to come off. There you go. And that little tiny pin falls out and gets lost. And that allows this to pull out. And this is actually a separate piece. Alright, let's see how stuck this retaining clip is. Not bad at all. That's some kind of little tiny shim there. More than one. Couple more shims came off of that. How do you like that? Alright, now I've got to get this key out of the shaft. Otherwise, the shaft definitely will not be able to move out that way. Will that allow that shaft to come out? Now, there is a worm gear on this shaft that engages a gear on this shaft with the pinion for the rack on the quill, this shaft right here. But according to the diagram, that is just key to this shaft and slid on it. So should be able to move this shaft out this way, and that should stay behind if it's going to give me any trouble. That's a little spring that goes underneath this key. That came out because I pushed that inner rod in the process of taking that out. I really don't want to bang on that with a metal hammer, do I? No. Oh, actually, the worm gear comes right out with it. There we go. Sweet. And it appears once the worm gear's out, might be able to actually pull this whole assembly out, maybe. Except for this unusual bracket assembly here that actually goes to that front lever that's removed on mine, because I had already sold it. So that's what it's hanging up on right now. But I'm seeing a pin. It looks like it goes right through this, and that's what that pivot's on. So just see if that pin will move. Moved a little bit. And it stopped. Maybe that pin doesn't go all the way through. Yep, the diagram shows that these are two pins. Doesn't go all the way through. It's two separate pins. Well, that makes sense too. Of course it can't go all the way through because this shaft is able to spin within this bushing right here. So this bushing and this must slide off of this thing, or disengage from this so that the shaft can go out the other direction maybe. So I've got to figure out, I don't know if that's a clip there or what. I'll try and pull this little key. No, that key appears to go behind this collar, so that collar has to come up. Oh, I just let that slide back down. That exposes the key. So now I should be able to get this key out. There we go. That's a Woodruff key. That now allows that to come up further, so let's see if now... once again, the secrets of assembly of this thing are revealed by the diagram. This is labeled in the diagram as a retaining ring, and sure enough, if I clean off enough of the gunk, I can feel that there is a break in this. This is not a solid ring. There is a spot right there. Not going to be easy. So instead of a nice retaining ring like those snap rings with the holes in them to put pliers in, this is just a retaining ring of the style that you have to get it started and then just kind of peel it up. This sucker goes around more than once. That's a funky little retaining ring. Now that whole assembly comes out. And so does this. And there's the gear that worm gear engages with. All right. Getting there. All right, so really all I could see left to pull out is this main drive shaft. This is the one that the plastic gear was on. And it's got a bearing on the top that was retained by 2 screws that I already removed. And it goes down inside here, and then there's a bearing in the bottom that's pressed into the casting. I don't see anything in the diagram indicating that that bearing is being retained by anything. And it looks like this hole is large enough to allow the worm gear to come out that way. So at this point, I think it's just a press fit that's holding it in there. So I'm going to try and grab onto this with my slide hammer. I have a slide hammer. Let's see if I can grab this shaft and tap it out. There we go. Pretty much in the home stretch here of stripping down this head. All I really got left to do now is there is that lever inside there. It's a a flat metal blade shaped piece that actually has the moving keyway on it. So that is activated by this lever on the side here. So I got a feeling the key to taking that out is probably going to be to take this off, which this whole assembly looks like it just 4 screws and this whole thing's going to come off. Not much to this. Yeah, that makes perfect sense to me. You see there's a shaft that movable key is on the end of, and it's got a groove in it right here that pin on this lever actually locks into. So that's why that shaft can't come out when this cover is in place. So now with this out, that probably can't go out that way because there's just a slot that goes through. I doubt. I could be wrong. If it doesn't go out that way, there is a plug, threaded plug right on the back here. You just take that threaded plug out and it'll probably come out this way. So that could be just for lubrication. I don't know. Let's just see if we could just push it all the way out. There we go. I am noticing there is a pin here on this side that it's kind of stuck in that piece. I don't know if that piece comes out or not. Try and knock it out and see if it moves. Yeah, that doesn't seem to be moving. Well, this part right here does seem like it's a completely different colored metal than the casting here, so I think this is a separate piece, and it looks like it maybe presses out in that direction, But I don't think I'm going to go through the trouble of taking that out. I don't think I'm going to find too many people that might have a need for it. I'm even going to leave this pin in here with it. This pin is, I think, a stop for the travel of the, actually I'm not even sure what that pin's for. Not going to worry about it. So I think we're going to call this quits here. I hope this video was helpful to anybody who might be working on one of these heads. That's the main reason I did this video. Not as fun maybe as some of my other little rabbit holes that I run down, but that's it. So all I got left to do here is clean up the rest of these parts that I'm going to save and catalog them for future reference in case somebody ends up contacting me and telling me that they need something from this thing. All right, so if you're not already a subscriber, please consider subscribing, and if you enjoyed this video, please hit the like button. Take care.